on bulbs. Actually, understanding bulbs takes more than 4-5 videos minimum, and this is the first among the many. Let us try to look at the problem regarding the bulbs. In any problem regarding the bulb, they will be asking like this. A bulb of 100 watt to 100 volt is connected across, let us say 100 volt. What will happen? What is the power consumed? Whether the bulb will glow or not? Whether what will happen? Suppose if this is connected with another bulb across 500 voltage battery, then will it glow or the fuse will be blown? So those questions will be asked. So before that, let us first try to understand what a bulb is and what is this thing. Every time they talk about bulb, they say this particular thing. This one, the wattage, it is watt. So this is called design power of the bulb. Design power. When they given voltage of the bulb, this is called design voltage. So what is the meaning? A bulb of 100 watt 200 volt means if you take the bulb of this 100 watt, when you connect it across the design voltage, let's say 200 volt, then the bulb will be consuming a power of 100 watt, which is the design voltage. When they say a bulb of 100 watt 200 volt is connected across something, if this particular thing we'll discuss about it. When they say there is a bulb of 100 watt 200 volt, when connected across 200 volt, it will consume a power of 100 watt. But there is more to it, because we know that power is equal to V square by R, which means R is equal to V square by P. And here V is 200 volt. They have given this is design voltage and this is design power. So substitute design voltage and design power. Design voltage they have given 200 volt square by 100 watt. So that is 200 into 200 by 100. Two zeros you cancel. So this is 400. So this means that this bulbs, if you just design power and design voltage then you can calculate the resistance of the bulb. This is the most important thing. So when you connect this bulb across any voltage, it is equivalent to this voltage. It is equivalent to connecting a 400 ohm resistor. This is what indirectly they are giving. The next thing is, we also know that power is equal to VI. Using this, I is equal to P by V. So here the power, design power they have given is 100 watt. Design voltage is 200 volt. So 100 by 200, which is 1 by 2 ampere, or in other words 0.5 ampere. This is the maximum current the bulb can withstand. This is the resistance of the bulb. Resistance of the bulb. Using the design voltage square by design power gives you the resistance of the bulb. Using the design power by design voltage, we are getting maximum current the bulb can withstand. Maximum current that this bulb can withstand. So anything more than that the bulb cannot withstand. So okay, let's try to interpret that. We say that using this, when a bulb is connected across this thing, when the bulb is connected across any voltage, it is equivalent to connecting a 400 ohm. Let us assume we are connecting this 400 ohm bulb across, let us say, 400 volt battery. So when you connect across 400 volt battery, this is the externally we are connecting. This is called supply voltage. Supply voltage. So the current in the circuit I is equal to V supply divided by resistance. V supply is 400 volt by the resistance of the bulb is 400 ohm. So what we are getting is 1 ampere. But what is the maximum current the bulb can withstand? 0.5 ampere. But now what is the current through that? 1 ampere. So the fuse of the bulb will be blown. So when when this bulb is connected across 400 volt, it does not glow. Does not glow, fuse will be blown. So fuse blown. Okay, this is the thing. And this is one thing. What if this bulb is connected across 100 volt battery? So actually what they have given, the bulb here is, look at this, 100 watt 200 volt bulb. So 100 watt 200 volt bulb connected across 100 volt. So what we said is, using this condition, if this bulb is connected across 200 volt, which is the design voltage, then it is supposed to be consuming the design power of 100 watt. Now you are just reducing the half of it. So when it is connected to, let's say, 100 volt battery, how much power will be consumed? This is equivalent to connecting what? 400 ohm, and this voltage is what? 100 volt. So you can directly say that the voltage across this is 100 volt. So the power consumed is equal to supply voltage square divided by R. The supply voltage now is 100 square divided by resistance of the bulb is 400. So when you connect, it is 25 watt. So when you reduce the voltage by half, actually the power reduces by actually 1/4. Why? Because when you connected this, let us try to understand this problem a bit more. When you connect this across 100 volt, we know that it is 400 ohm. So the power is also equal to I square R. So the I here is V by R, right? So 100 by 4, which is 100 by 400 square into resistance 400. So 100 by 400 is 1 by 4 whole square. So 1 by, because 2 zeros will be cut, 1 by 4 into 1 by 4 into 400. So this is 100. 100 by 4 is again 25 watt. So this is the whole thing. When the design power and design voltage given, using that calculate the current of the bulb and the maximum current through the bulb. Using that we can process the other information. So I'll discuss one more problem on this in the following video.